All right, this is the example that's in the book, example number 6, section 4.6. It says we have a half-life of 140 days. We're starting with a mass of 300 grams of something. So that's our starting value. 300 would go here. And the step letter A, it says come up with a formula. Well, here's the formula, but plug in what we know so far. So it would be A equals starting with 300. We don't know the time, but we do know the half-life is 140 days. That would be the formula for part A. Part B, they want a different formula. They want PERT. So we have to convert from half-life to a rate. That's an R right there, P-E-R-T. And here are the two formulas. You may want to have them written down somewhere where you can get to them. If you know the half-life, you can find the rate by this formula. If you know the rate, you can find the half-life. They look the same, they just swapped the two letters. So we know the half-life is 140, so go ln a half, parentheses are hit equals, and then divide by h, and you'll get the half-life, you'll get the rate rather, and the rate. So now we can finish this. The second formula, which is PERT, would be starting with 300, E, and the rate on your calculator should be negative 0.0095. And then time goes right here, P-E-R-T. This is the answer to part B. Part C says, I think it's 1 year. How much will be left after 1 year? Now, these are both times. That's the time of the experiment and the half-life. It's in days, so time has to be in days also, and it says 1 year. So don't put a 1 there, put 365. But you have your choice of which way you want to do it. You can use PERT or you can use half-life. If you use half-life, it's 300 times time of the experiment over the half-life. So this would be the half-life formula. You can try that on your calculator. And you should get around 49.3 milligrams. Or you could do it this way. No, that was half-life. Where's PERT? We could do it in PERT. Negative 0.0095 times 365. This is part C. I've got a little squeezed in here. We got a lot to go over. All right, so this is doing it with the half-life formula, and this is doing it with the PERT. And you should get the same answer either way, 49.3 milligrams. Now, the next to last part is, how long does it take to go from 300 down to 200? You can use either formula. This is called PERT because you see an E. If you see a half, it's called half-life formula. Half-life formula, PERT formula. It's P-E-R-T, but if you see the E, it's going to be PERT. So what's the first thing you do if we're going to use this formula or this formula? Since you know both A and P, you're always going to divide those two. 200 divided by 300 reduces to 2/3. Then the log, we have to go to log. Anytime you're solving for one of the exponents like t or h, you have to go to a log. It's E over here, base E, of 2/3 equals negative 0.00, can't read my own writing, 0.00 .0095, I think it was. Yeah, 0.0095. Oh, why is it negative? In PERT, when R is negative, it means it's going down. And half-life is always going down. That's why you'll see a negative. And we need a T out here. So do this on your calculator and divide by that, and you should get 81.9 days. Now, if you want to do it with the half-life formula, again, you divide these two and get 2/3 of a half raised to the T over 140. So we've got to go log. What's our base? Well, this has the exponent, so it's base a half of 2/3 equals T over 140. So do this on your calculator. Hit log, put a half in the small box, 2/3 in the big box, and then multiply by 140. And you should also get 81.9 days. On the test, you can use either one. You can use PERT or you can use half-life. But on the homework, they wanted you to do both of them. And there was one more part. They want you to graph it. Anytime it's decay or half-life, it's not going to be growing. It's going to be decaying. And what's our y-intercept? Normally it's 1, except we've got a number in front. So this time the y-intercept is 300. The y-intercept is 300 right there. That's what y equals. Don't worry about exactly where it is, but you know it's coming down and it's going through 1 unless there's a number in front, then it goes through that number. All right, that's an example out of the book, example 6 in unit 4.6.